Hi, this is Dr. Michelle Woolhouse. Join us on FX Medicine next week, where we'll be talking to Dr. Ross Walker about the benefits of coenzyme Q10 and how we can use it to help both ourselves and our patients. Subscribe to us on your favourite podcast app and follow us on social media to make sure you never miss an episode.
Hi, and welcome to FX Medicine by Biophysics, where we bring you the latest in evidence-based, integrative, functional and complementary medicine. FX Medicine acknowledges the traditional custodians of country throughout Australia, where we live and work, and their connections to land, sea and community. We pay our respect to their elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Joining us on the line today is Dr. Christabelle Yeoh. Dr. Yeoh has over 2 decades of experience in clinical care, most of which has focused on understanding the root causes of chronic disease. She works with her patients to optimise their biophysical health, mitochondrial health, digestive function, microbiome, and brain performance. She applies the premise that dysfunctions can be corrected with established practices of nutritional and environmental medicine and selective rehab to support neuroplasticity. Christabelle dedicates her practice to working with patients with complex chronic conditions, neuroimmune-mediated or chronic inflammatory illness. Welcome to FX Medicine by Biophysics, Christabelle. We are so excited to have you here with us today.
Hello, Lisa. Thanks for asking me.
Oh, such a pleasure. Now, I saw you earlier this year at a fertility seminar I was presenting at, and I was outside calming my nerves after having completed my presentation. And you don't know this, I saw you outside with an exercise rope, and it wasn't a skipping rope. It wasn't a skipping rope. You were doing some sort of upper body exercise with this big rope that was kind of like those CrossFit ones. And now that I'm saying this, it sounds super creepy that when I'm saying it out loud, that I was watching you and you didn't know. What a creep. But let me redeem myself by saying I was watching you thinking, wow, this is a physician that walks the talk. You're outside getting fresh air, sunlight, moving your body, which, you know, most of us rarely do when we're at those seminars all day. And then later on in the day when we were back inside and another Dr. Natasha was presenting, and I think she made you come on stage. I can't really remember what was happening, and I just remember maybe you did some sort of exercise regime that everyone took part in. But what I do remember very, very well is that the room was buzzing with energy, and you yourself just exuded this vibrant, special type of energy, which I can't describe. You just have to see you to know. And I remember thinking, because I already knew that you specialised in mitochondria, and I wanted to ask you on the podcast, but I was too scared at that point, and I was like, I need to know her secrets about the mitochondria. What are they? What's she doing? So here we are today, and I can't wait to delve into navigating the topic of the mitochondria. So I studied biochemistry 25 years ago. It's very, very old in my mind, so I think a good place to start is maybe if you could give us a refresh on what the mitochondria are and their function in the body.
Okay, cool. Thanks, Lisa. That's quite a funny introduction. And actually, I really loved your talk at that fertility workshop because you mentioned one of my favorite things that I always end my presentations with, which is change your light health, or, you know, use light to improve your health, because you talked about Zeitgebers. So I was like, yes, I wanted to stand up and clap. But yeah, so really with the mitochondria, okay, we could start about, you know, we can talk about cell biology, which is really the what, but there's also the evolutionary biology, which is the why. And so the what, you know, mitochondria are organelles in our cells, and everyone thinks that they are the energy producers, and they seem to have got this title of powerhouse of the cell, which I keep reminding people that is outdated, and stop saying that because technically mitochondria are not production organelles. They are processing. So that might be a bit of semantics, but actually the semantics brings us into the why. So they are energy processing organelles. They are not producing technically. And an equivalent to the energy processing concept is you have to think about a capacitor. So mitochondria are capacitors. And if you know a bit about electronics or physics, then you'd get that. But also equivalent to a capacitor is a battery, which I think most of us are more familiar with. So a battery, you've got charge or you've got empty charge. Is your phone empty or full? And if it's empty, you just charge it back up. And our mitochondria are actually like that. They want to be charged up with some other of nature's forces, which we will go into. And then when we charge it up with all of what and why, nature built our mitochondria that way, then we have energy from there. They're not just there to give us more and more energy because we demand of it. We have to give it its inputs, and then we get the outputs.
So it makes sense. They're processing our energy, not producing. Is a better way to think of them.
Yeah, I mean, it's true, right? They help us produce our ATP, and that's what we all learn from biochemistry. That is our energy production line. But just before that energy production line, what else is going on? So there's a little bit of a what as well as a bit of a why, because the ATP is not just being produced there for us to run and study and work and, smash ourselves, which people like to do these days. But our energy is really, what is ATP there for? And this has been very much the last decade of my mitochondrial education, ever since that wonderful paper from Robert Naviaux on the cell danger response. Like we always thought in, nutritional biochemistry and so on that, we just need to use all the cofactors and so on to get more and more ATP. But actually, we should understand that ATP is a molecule that has a lot of other functions in nature, and inside the cell, ATP is doing what you want it to do. But outside the cell, ATP is a danger signal, which is what the cell danger response is all about. So why would a cell feel like it's in danger? And then this is where environmental medicine, nutritional medicine, we know those. Like everyone listening to this already knows what makes the cell feel like it's under the pump and in danger. But it's because of that cell danger response that then the ATP production line slows down and in fact is starting to drive danger signals or mitokines that would signal other inflammatory pathways. So ATP is not just that thing you just want. It's more like what is it doing? Why is it doing that? And where is it balanced?
So are you saying that ATP outside of the cell could encourage inflammation?
Yes, so this is all about the cell danger response. So ATP is an intracellular and can be also extracellular. So when the mitochondria are working as they would say naturally, it's dealing with cellular resources, it's handling nitrogen, oxygen, iron, sulfur. It's doing its thing with, managing innate immunity. So I'll just go back first to the roles of the mitochondria before we move into that intracellular, extracellular ATP. So the mitochondria really, from an evolutionary perspective, there to balance cellular redox and reactive oxygen species control. And it does that because it uses ROS as its first steps in innate immunity. So over 2.5 billion years ago in the Precambrian time, and we're just a sea of viruses and there's no multicellular life forms, and we just have all these ancient bacteria, these alpha proteobacteria, and got viruses, and it's just like fighting for resources, electrons, protons, iron, sulfur. And it's really just a game of electrons as resources. But that's the way our cellular capacity handles our redox. It does it really to deal with viruses, and it fights. And that's that innate immunity. So our mitochondria are the first responders in a viral response. And that's why we saw in COVID, so many people have varying degrees of metabolic syndrome, and those are the people that then struggle with their metabolic flexibility, and are they going to get fatigue or pick up from that viral illness? So that role of the mitochondria as evolution would have it, first steps first, it's innate immunity, manage your cellular redox and ROS control, use your oxygen. So that's what these ancient bacteria, which became our mitochondria, were good at doing. They were good at using oxygen. They have to be able to use oxygen to balance ROS. And then when those things are looked after, then you start pumping out ATP, and then the ATP synthesis starts to move down the evolutionary chain of how we became more and more complex organisms. We can crosstalk with peroxisomes, we can do cellular work, cell growth, cell death, apoptosis, cell repair, autophagy. Then we can manufacture proteins and all their genetic, epigenetic signals, nucleotide synthesis, GTP, UTP, etc. And then we can drive methylation. So, from my perspective, dealing with methylation before mitochondria is putting the cart before the horse. The mitochondria look after cholesterol. They look after glycolate and oxalate metabolism, all those patients with leaky gut and oxalate issues. They look after vitamin D activation and inactivation, all those patients with inflammation, and you give them 10,000 units of vitamin D and you wonder why their levels don't go up.
Definitely.
And then the porphyrin and iron metabolism. So those are your patients with ferroptosis and high ferritin after viral illness, i.e. COVID. And then calcium regulation, which is so important for looking after the nervous system. And then meiosis, so reproduction.
Wow. So I was under the impression that we manipulate the mitochondria, but as you've emphasised, it's actually the mitochondria that are manipulating us.
Yes. just as we learned, in the last couple of decades of nutritional medicine, our microbiome are manipulating us, like we're just the puppet to our microbiome, and that is correct. But the mitochondria and the microbiome are a bit similar in that they were both ancient bacteria speaking to each other, and our microbiome can sense what the mitochondria do and vice versa. So just as everyone knows the microbiome control us, then remember that the mitochondria control us as well. Hence, I was saying, okay, it's how do you navigate, because we can't manipulate them.
And it's like, from what you said with regards to methylation and everything, it sounds like the mitochondrial health needs to be the starting point.
Needs to be the starting point. And it probably, when people talk to me, they're like, oh yeah, she's going on about mitochondria again, and those rose tinted glasses, and if all you've got is a hammer, everything looks like a nail. But I just can't help it, because if you really, many of us like to think about health ancestrally from an evolutionary perspective, and people who are microbiota minded will think that way. And about our paleo diets and how we eat, people will think that way as well. So just thinking about the mitochondria is no different, really. It's thinking about the why they're doing what they do, and from an evolutionary perspective, like the mitochondria ideally is working really well for all the other cellular processes to work well. But the human body's got such an amazing capacity and plasticity and give, like it's so forgiving. We can really smash it, hard, and then some of us are luckier than others, of course, but there's a lot of give, but it's just some of those things. Like if you see ferroptosis, you know you need to go to the mitochondria. If you see those vitamin D levels that won't go up, you know you need to go to the mitochondria. You've got those complex methylation patients that you try and improve their undermethylation, and then they have a bad reaction, you need to go to the mitochondria, and so on and so forth.
It's super interesting. So you talk a lot about hormesis. Can you, I hope I pronounced that right, can you explain what it is and then the concept of mitohormesis?
Yes. So hormesis is a term that's been around in the scientific literature for, many decades. And the big researcher there is Calabrese. But the biological understanding of hormesis is that it's a biological phenomenon that was discovered in living organisms, that if we're exposed to a low-dose toxin or a short-term stress, it's actually beneficial. So in the end, there are beneficial effects seen. And it's a U-shaped or biphasic curve, in that if it's a higher dose, it can become harmful. And so in many circles, from homeopathy to toxicology, especially that hormesis has been looked at in all sorts of ways. But in the more recent decade or two of mitochondrial science, it's become a big darling in the mitochondrial world, because hormetic pathways are all conveyed through mitochondrial pathways. So, and it comes back to evolution. It's like, what doesn't kill you makes you stronger. Stress yourself and you grow faster and you evolve and you get stronger. So it's really all about adaptation, resilience, and ideas, evolution, even if we think we have evolved to the top of the line. I mean, some would say we're possibly devolving now, but the idea is that that's what mitochondria were built in to be able to do like 2 billion years ago.
So then acute stress optimizes mitochondria. And would that be things like psychological stress too, or just things like fasting or heat, temperature stresses?
Well, to be honest, it's actually all of it, because if you're really holistic about the mitochondria, and I prefer to educate people on epigenetics in the context of mitochondria, and I guess we'll come to this later, but I put down as many things as I could think of how we live, grow, survive, thrive, living on this planet. And it's all of those factors. So there's nature forces and what the earth gives us, which is the sun and magnetic fields, go off to the moon and your bones will disappear, And then there is water, and there is temperature, and then there's the sun and the moon, so there's light and dark, and then there's all the microbes we evolved with, and then there's toxins in the natural world. Of course, there's toxins primarily in plants, but fast forward to the toxic world today, we've got many, many, many more toxic burdens. And then we have to consider the nutrient supply. So that's not just feeding, but fasting. And then we consider how we move our bodies. So the modern language is exercise, but in the past it was just move. And you had to run and climb and crawl and swing your axe and
I love that distinction.
Saw me doing all those funny movements.
You'll have to tell us later what exactly you were doing. It was very inspiring. Yeah, okay. Well, since we're talking about exercise, I think, there is so much incredible research when it comes to movement really being important for mitochondrial health. And I've never even thought of this before. I think as practitioners, we really learn a lot about CoQ10 and B vitamins and things like that, but less so about the lifestyle strategies. And for me, the lifestyle strategies are just so so important because they're so practical, they're free, they're relatively easy. And I was reading this paper with regards to exercise and mitochondria in our skeletal muscle, and basically you'll be able to tell me more about this, more about this to all of us listening, that mitochondria in our skeletal muscle synthesize more ATP when we are moving. And they also get rid of the old mitochondria, so a bit of mitochondrial quality control, kind of like taking out the trash, which I just thought was fascinating, like so clever that the body does this just in response to movement.
Yes, yeah. Yeah, so what you were speaking to is the fission and fusion. So mitochondria have different shapes, and they can be long like spaghetti or short or balls like meatballs. Mitochondrial research call it meatball and spaghetti configuration of fusion and fission. And they literally creep around the whole body, all the tissues, everywhere. The only place where we don't have mitochondria in our body is in the red cells, but it's incredibly dense in the muscles. It's incredibly dense in the nerves. And yeah, so any movement, how I like to see it is that the mitochondria are just there behind the scenes to drive plasticity. And I'm not a big sports science person. I just keep it simple for the patient, like, well, use it or lose it, basically. And it's the mitochondria behind that. So the more we use it, the more we facilitate a movement, an activation, a connection, essentially that's plasticity, then the responsiveness of the system, because the mitochondria is listening to the entire environment, the electrical environment, the chemical environment, the feeling environment. And so that's this fun new area called mitochondrial psychobiology.
Wow.
But yeah, so it's in that field, essentially it is a biophysics feeling machine. And so any activity we put through the system is going to move it. And as you say, those electrons have to move through the electron transport chain. So let's say if we are overeating and then there's a lot of electrons, but we're not using the energy and then the electron can't go down the electron transport chain. And then that excess electrons oxidizes other molecules, and that's just that whole balance of redox, reduction, oxidation reactions, all about balancing your electrons and your protons.
So then in a situation like that, often patients feel fatigued and brain foggy and lethargic. Is that what is going on, that there's mitochondrial dysfunction?
I would dare say that brain fog is mitochondrial dysfunction, meaning, not optimized, because as you know, there's the disease and then there's the dysfunction. So we're not talking disease at all, but dysfunction also probably can be 0 to 100. And the brain's only like 3% of the body's weight in total, but uses over 20% of the body's energy, glucose. So the brain is super resource hungry, and if the mitochondria are only stuck in glycolysis and don't go on to the electron transport chain and fatty acid beta oxidation to keep giving you a bit of a marathon output of ATP, and you're just stuck on the 2 ATP and you don't get the other 30, ATP, that thing that from biochemistry, then yes, the brain could easily feel foggy because it's just under-resourced.
So within your clinic, because I know you've got a busy clinic, what sort of things what sort of kind of presentation would you see in your patients? And I guess for pracies listening, what should they be aware of in terms of client signs and symptoms? Because patients don't come in and say, I've got mitochondrial dysfunction, in the same way that they might come in and say, I've got iron deficiency or Hashimoto's.
Yeah. Well, I think all pracies will know that, chronic fatigue syndrome, ME, CFS, mold illness, the more severe end of the gut-brain spectrum, functional gut disorders, brain fog, as you were saying. I think everyone will know that mitochondria will be behind that. But then, so let me just speak to perhaps where it might not seem so obvious. In saying that any spectrum of chronic fatigue syndrome where a person gets symptoms, so whether it's post-exertional malaise, and it could be mild, it could be severe, and we're not talking about not being fit, like gradually if they exercise and they can tolerate it, that's just not what we're talking about. It's people who can't get over that hump of what they think they should be doing exercise-wise, but they just keep getting PM. So, of course, it's definitely mitochondrial. But any patient that we might detect that fits in the autonomic dysfunction camp, and maybe they don't have huge complaints of fatigue, but perhaps they have temperature dysregulation, perhaps they have gut motility issues, bladder irritability, instability issues, all the autonomic things. You might put their digestion, poor vagal tone in that camp as well. If you might see pupils that don't respond well to light, they kind of constrict as they should, but then they flare up again because those pupillary muscles are so tired, the mitochondria there aren't working. They might have a degree of postural orthostatic tachycardic syndrome. So those would be like a lot of the symptoms and signs. And sometimes you have to go back into the history and you ask, well, always ask about the maternal line, because an unwell mother with a range of issues from neuropsychiatric to fatigue to autoimmune to poor conception, infertility, all of that means the mother's mitochondria are not happy. And of course, the person inherits the mother's mitochondria only, not the father's.
Oh, wow. I didn't know that. That's incredible.
Yeah, that is. So that's why that fertility workshop and,
the preconception.
Preconception for a year,
Oh, gosh.
Really, that's so important because we're passing our mitochondria down the maternal line, and many people in environmental medicine world and all the books written on it will say that's why we have so much autism, like the 5 A's: autism, allergies, ADHD, autoimmune, and I can't remember the last A, maybe Asperger's or something. Asthma, that's it. Absolutely.
It's like a game that we were playing.
So down the maternal line, so always get the maternal history. And then as a young person, that child may have low muscle tone. They didn't really like exercise because the muscles aren't great. They got fatigued easily. They end up just being a bookworm. Or, an 18-year-old boy and they finally want to look muscly and they go to the gym and they're working out like crazy and then they're so frustrated because the muscle bulk will not build. That's very classically mitochondrial.
So you just said before that, you're suggesting like a year of preconception. Do you think that, is that the timeline it takes to make big changes with mitochondrial health?
I think it depends on the baseline where people stand. And, I'm sure we don't, even if we think we're healthy, we're not at that 100. I said sort of 0 to 100. So how do we know if a patient's standing at 20 or 50 or 70? And unfortunately, there is no test for this. I keep my eyes out peeled for an in-clinic test. It's not here yet, but it will be coming because we can test for mitochondrial heteroplasmy in the labs and then research, but not in clinic. So mitochondrial heteroplasmy is the genes that are in the mitochondria, all 32 or 37 of them, can't remember now, very few compared to our nuclear genes, which is 20,000. But they are all the bioenergetic genes. So when we get that from our mother, and if our mother didn't have a good lifestyle, a lot of stress, inflammation, and so on. And then the mitochondrial epigenetics is not happy and there's a lot of mutation in the mitochondrial genes, then at that time that would be what would be transmitted to the child. However, it's not as linear as that with nuclear genetics and what we know, more like the simple form of Mendelian genetics. There's much more of a wild card or gambling your luck, because the mitochondrial heteroplasmy, the way they mutate and shift, is far faster and far more variable than like their DNA. So from that perspective, things can definitely change very well quite quickly for. But if someone, I think, has a very low starting base, then I think, I don't know what you can change. And this is not in the literature at all. Like this would be Doug Wallace's work on mitochondrial DNA genetics. And they're still really very much working in the field of diseases and disorders, MELAS syndrome and all these known like congenital disorders. They're trying to work out what happened and what was the mitochondrial genetics there and what percentage of threshold causes the disease. So if there's more than 70% threshold of mutated mitochondrial genes, so heteroplasmy, then the biochemical functioning is really notably bad, and then you might have a child that would die young. But if it's 30% mutation, then you might have someone present at the age of 40. Or if you have, 50% mutation, maybe they present at the age of 20. These are all still being mapped out, and it's extremely complex. So Doug Wallace talks about what we think should be simple, like metabolic syndrome and diabetes and high blood pressure. He talks about them as common complex diseases, because actually it's very complex to work it out.
So complex. I agree. I totally agree. They sound easy in theory, but then with some patients they are, but then you have other patients where it's just so much more complicated than that. Yeah. So you were mentioning testing, and there's no specific test, but what about blood? Is there anything in the blood that you would kind of be looking at? I'm thinking,
Yeah. So blood testing, I would always you do a full chemistry panel, and then because metabolic syndrome is a consequence of mitochondrial dysfunction, you'd always test the metabolic side as much as you can, insulin, leptin, HbA1c. But sometimes people eat quite well and they exercise, and that you can't see anything there. But for many people, their insulins are suboptimal. It should be around 6 or 7 or under. And then the leptin should be in the normal range. That's a big one. And then the HbA1c in the functional world, we like it close to 5%, not the 5.5%. So even though it's not a diagnosis of mitochondrial issues, just a lead towards what to work towards. But otherwise, in the blood markers, sometimes, not always, I don't know, in my clinic, a quarter of the time, so it's quite often, but I have a chronic fatigue clinic, I will see a high CK. And that's a high CK in someone who isn't lifting weights and doing a lot, but this is, they're still living, trying to live normal life, go shopping and go to work and things. But their mitochondrial capacity, redox capacity to kind of heal the broken muscles and releasing the muscle enzymes isn't keeping up with the demand. So that's a very clear one. When you see it, then you know you got something there to improve the baselines that usually should improve.
Yeah.
And then other things on the biochemistry, like not anything really, things like liver function, LDH, if those are abnormal, it really is a significant inflammatory fatty liver, all of the like NLRP3 inflammasomes, all the things that, we'd talk about in nutritional biochemistry is already all an issue.
So the CK creatine kinase and the LDH lactase dehydrogenase, they are markers of tissue damage, right? Like, so
Yes,
that we're seeing, are they enzymes? Or
they're
enzymes leak, like breaking down. Because I've seen high creatine kinase in hypothyroidism where there's that breakdown. I've seen it, obviously where there's been a heart attack, lots of recreational drug use and things like that. So they would be situations, I guess, too, where there's that poor mitochondrial function.
yes.
And then the liver function tests as well. Super, super interesting.
Yeah. An organic acid test would be the one that many pracs listening to this will be quite familiar with, that there are a number of mitochondrial parameters on the OAT test, but from the medical perspective, they don't recognize that as mitochondrial testing. So in a neurology clinic, if a patient has got, quite significant, maybe a degenerative muscle disorder or something, they'd look at CK, and then they would do muscle biopsies to actually establish the mitochondrial disease / dysfunction in the lab. But that's not what most of us would do.
Yeah. Okay, interesting. So we've talked a little bit about exercise, but let's go to the concept of Zeitgebers, because we're both very, very much into those. Zeitgebers are, of course, those environmental cues that regulate our circadian rhythm, and melatonin is one such Zeitgeber, which, interestingly, I didn't know this until I was doing research for our podcast, there's melatonin in the mitochondria of all cells, which is wild, right?
Yeah.
So then,
decades of melatonin research, and we all love melatonin, and then suddenly it's like, oh, it's squarely in the mitochondria. So that's a huge part of mitochondrial health, because our mitochondria make melatonin, and then they do so thanks to the light signal, and then in doing so, being a very powerful scavenger of Mito-Ros, improving superoxide dismutase, glutathione peroxidase, catalase. When you do those epigenetic tests and then the patient's got SNPs in SOD and catalase, and you're thinking, oh, what can I do supplement-wise? Well, you can't do anything, but you can do a biophysics or circadian prescription, because if the mitochondria are happier, they make more melatonin, they'll improve that SOD and catalase, and then they stabilize the mitochondrial membranes and all the transition pore proteins, the things that stop the mitochondria from being leaky. And that brings us back to the cell danger response, because it's when there is leaking out of ATP, out of the mitochondria, and then the cells going, oh no, this doesn't look good, this doesn't feel good, the alarm bells are ringing, ATP is leaking out. And that's what's happening with these membrane pore proteins. So melatonin helps to stabilize that ATP doesn't leak out. And then, of course, it helps with the calcium homeostasis, mitochondrial biogenesis, reducing NLRP3 inflammasome. So a lot of those things that we like to use supplements and lifestyle to support melatonin from the mitochondria is a big sort of pathway behind that.
So then what impact do you think our modern day living and this 24/7 exposure to light, but that what our other ambassador Michelle calls junkie light, has on mitochondrial function? Like, it's probably not good, is it?
Well, I dare say, I think in another decade, we will all just know and blame the blue light for metabolic disease. So, at the moment where many of the mainstream people are saying, oh, they're just eating too much, not exercising enough. But, if you know a little bit about mitochondrial chemistry, you'll know, okay, it's not just that. Like, my patient's mitochondria is stuffed full of toxicity and heavy metals, and then they're eating too many carbs, so that itself is a very inefficient fuel. And then we improve those things and things get better. So we know, metabolic syndrome is mitochondrial in nature, and then you just wind it back a bit more and the blue light is basically stuffing up our mitochondrial bioenergetics. So I used the word biophysics a few times, bioenergetics. It's really just connecting physics to chemistry, because our body is not just a bag of biochemistry. We're some more magnetic, electric beings. I mean, in the end, the mitochondria is producing, between the electron transport chain, the complex 1 to complex 5, that is producing 30 million volts per meter electric field. Lightning is 300 million volts, and we're producing 30 million. Like,
That's crazy, isn't it? Wow.
We're just like walking lightning bolts. We should be. We should be. And we should be full of energy, but we're just getting so many thieves
bogged
of
down.
Our cellular ATP. And this is actually how Robert Naviaux talks about it. He talks about metabolic thieves. And in his papers, it is heavy metals, toxins, pathogens. But pathogens is what was expected in nature. Toxins is where we've gone wrong against nature. And then nutrient demands. And so that's that balance of how we eat, macronutrient balance, pumping those resources across the electron transport chain. So eating a lot of carbs, not exercising. That in his world, and that's a metabolic thief that is stealing resources from us.
So we've like, those thieves are really common for so many of our patients. And I was reading a really interesting paper this morning that was examining the use of mindfulness-based intervention on mitochondrial health, which I thought was really, really interesting. And it was a randomised controlled trial. Essentially, the participants who did mindfulness had reduced mitochondrial oxidative phosphorylation, so better mitochondrial health. And they also had higher brain-derived neurotrophic factor, so very good for the mood and all that sort of stuff. And I thought, if a mindfulness intervention can do this, then I'm wondering, to what extent do you think the bad psychological stress that so many of us encounter on a daily basis with traffic and poor relationships, we've talked about those thieves in terms of viruses and pollutants, but what about bad psychological stress? Do you think that can impact our mitochondria too?
Yeah, absolutely. I think it can impact. I don't know if I would call it a thief. Maybe when it starts to become in that difficult vicious cycles, and certainly when there is neuropsychiatric syndromes and depression. And, we know from Chris Palmer's work, the psychiatrist who wrote the book Brain Energy, he's talking about how depression and all these psychiatric syndromes ultimately is mitochondrial. But to the paper that you just described, I wonder who wrote it, whether it's Martin Pickard. And Martin Pickard is his lab and his work is going to be the one to follow in relation to what you just described. And it's really early days of that sort of work. And he has a mitochondrial psychobiology lab.
Amazing.
And Martin Pickard was Doug Wallace's PhD student. And he is, you could think about the mitochondria bottom up, top down. So if it's bottom up, it's like feeding it the nutrients, not loading it with toxins, detoxing, that sort of thing. But then maybe we could think about it as top down as well, that the signals it gets, because it is a sensing processing system, and our thoughts will definitely be one aspect of that sensing and processing, for sure.
Now, you mentioned before, which I was like, oh, this sounds very exciting, biophysics prescription that you give. I assume that's like a prescription that you give your patients, but centered around lifestyle?
Yes, centered around lifestyle, centered around light. Really, the education is around how did our mitochondria evolve in nature, and then therefore the sicker a person is, the more they have to leverage nature. And it is usually these patients who don't do well with drugs, developed side effects, got all sorts of, issues like this is a classic one. So a patient with low ferritin, GP whacks in 2 vials of iron, a lot. That's 1,000 milligrams of iron. And then the patient has fibromyalgia and pain for 3 months. So, iron is a double-edged sword as well. It's an oxidative stress. And it's the redox capacity that could not handle that iron, because iron overload is inflammatory, aka ferroptosis. So the biophysics prescription that I give is really, it's first mimicking nature would be watching the sunrise and the sunset, because sunrise and sunset give us the most powerful signals of infrared light, and the mitochondria respond very much to infrared light. Of course, the whole light spectrum of the visible light of the sun going through the day is that clock, is our clock. So I tell my patients, sunrise, sunset, clock in through the day. So even if it's 5-10 minutes every couple of hours, just go outside for 5 minutes, leave the computer, go outside, and then each time your eyes see the light, no sunglasses, please, then the brain gets the full upload of what time is it based on the earth and the sun. And then that talks to our metabolism, talks to the entire neuroendocrine system, everything, metabolic, biochemical, local systemic signals that enhance the whole adaptation of the mitochondria or the organism to your ideal nature. So that's that. And then don't block nature. So blocking nature would be when the sun's gone down and we got all the lights on, and we're sitting around in blue light. So people really should have bulbs that block blue light. They're called biolights. So they can flick switches to have a different amount of blue as it goes through the day. So by the time it's evening and night, the light's very orange. And they're available on the internet, biolights. But not everyone's going to go around changing their light bulbs like I do. So then they just wear blue light blocking lenses and glasses, and then you might have a very light yellow for the daytime in your screen, and then a darker orange for the evening, and then a even darker orange for the last hour or so before bed.
Beautiful, beautiful. So simple, but so powerful, I think.
Yeah, so it is so powerful. I can't tell you, Lisa, because when we run retreats and we do this for people, because, during the retreat, we're up watching the sunrise. We watch the sunset, and the property is all block blue light lighting, and then we eat in the daylight hours. So the circadian prescription is also to eat only in the daylight hours. There's a good reason my chickens don't eat when the sun goes down. And so eating at the right time is a big signal, although the light in the brain is a bigger signal than the peripheral clock signals. And then the other biophysics prescription is grounding in nature. So barefoot on the grass, get in the sea, or get in the lake, or just connect to nature and the earth's grounding field.
Sounds horrible. So lovely. No one ever felt worse, right? Watching the sunrise or the sunset or having a little dip. No way. Yeah, beautiful, beautiful, beautiful. So what's super exciting for you in terms of the latest research? Is there anything like really big or that you think that prackies need to know about, or anything that you're really excited about when it comes to the mitochondria?
Well, I think people are going to realize soon that we said earlier about how we're puppets to the microbiome, that actually we're even more puppet to the light, and there's already plenty of research, not a huge amount compared to the thousands and thousands of papers of photobiomodulation in all sorts of conditions, especially neurological. So using red light therapy to treat conditions, it's quite exciting. That's great. But, I think many prakhis will know that already, and light therapies have been easily available for the last decade. A lot of chiropractors will use medical lasers. A lot of us will ask our patients to buy red light panels. You can go on a red light bed, all that sort of thing. But it's also showing up that it's light that changes the microbiome, because our metabolome, the metabolic signature of our microbiome, is completely responsive to our circadian signals and light exposures.
Oh, amazing. Thank you so much for joining us today, Christabelle. I so greatly appreciate that you've taken the time to share your knowledge with us, but especially your passion that really shines through, and your reinforcement in highlighting the power of these really simple, practical lifestyle strategies such as light, movement, and that beautiful biophysics prescription, I think is just so powerful, and I think prakhis can just implement, with their patients straight away in clinic.
Thanks for the opportunity. I could go on for hours.
We'll have to do a part two.
Talk about it. So thank you for having me on.
Oh, pleasure. Thank you everyone for joining us today. The key points I have taken away, there's so many, but the key points for me would be that the mitochondria are processors of energy, not just producers of energy, and that poor functioning of the mitochondria leads to increased oxidation, decline in ATP, which promotes chronic disease. Strategies to support the improvement of mitochondria are exercise or movement, and watching the sunrise and sunset. I love it. Don't block nature. Thank you everyone for listening today. Don't forget that you can find all the show notes, transcripts and other resources from today's episode on the FX Medicine by Bioceuticals website, fxmedicine.com.au. I'm Lisa Costa-Bir, and thanks for joining us. We'll see you next time.
Enjoyed this episode? Subscribe to FX Medicine by Bioceuticals on YouTube by pressing our logo. You can also head to bioceuticals.com.au/education for more healthcare professional resources.